Okay, this is video 4 in the lesson 4.01, and we're graphing systems of equations here. And in this one, we are solving a real-world system of equations. A high school is putting on a Broadway musical. The auditorium has 400 seats. Student tickets are $3.50 each, and adult tickets are $6.50. The school must make $1,800 to cover expenses. Make a graph to find the combination of student and adult tickets needed to fill the house and pay the expenses. So I've written down the steps over here. Let's see, you can, there you go. So step 1, identify the critical information. Step 2, create 2 equations. Step 3, write the equations in slope-intercept form. Step 4, graph the equations. Step 5, analyze the answer. All right, so in this situation, we have 2 kinds of tickets. So we're going to have 2 variables. We don't know how many of each kind we need to sell. That's what we're trying to figure out. So we're going to let X equal the number of student tickets sold. I'm just going to write student ticks like that. And let Y equal the number of adult tickets sold. Okay, so we have 2 variables, X and Y. Step 2 is to create 2 equations. So if the X and Y are the number of student and adult tickets respectively, we know that there are 400 seats and we need to fill all of those because it says that we are filling the house. So we know that X plus Y equals 400. And so the other thing that we also know is that, and I'm going to label these in this way, the student tickets are $3.50 and the adult tickets are $6.50. Okay, so the reason why I wanted to highlight those is because here we have the student tickets are X. That means that the X, each X ticket, the student ticket, is $3.50. And so we need $1,800. That's going to be our total here. So I'm going to scoot this over just a touch. So $3.50, 3.5 times X. So this right here, that is the total amount of money that they will make on student tickets. And then we're going to add to that the $6.50 times Y, because that is the total amount of money they're going to make on adult tickets. Now, when we add those 2 amounts together, sorry about that, they need to equal a total of $1,800. So there are 2 equations. Notice that the first one is pretty close to slope-intercept form, y equals mx plus b. All we need to do right here is to subtract x from both sides, and we get y is equal to negative x plus 400. Over here on the other side, we're going to need to, first we subtract 3.5x. And when we do that, we're going to get 6.5y is equal to negative 3.5x plus 1,800. And the last thing we need to do is to finish solving for y, we need to divide by 6.5. So when we do that in this situation, divide by 6.5, divide by 6.5, divide by 6.5, we're going to get y is equal to, and I'm going to pull up a calculator here so we can make sure we get that right. Boom, magic. So we have negative 0.538. Now notice that that is an estimate, negative 0.538x because that's what we get when we divide the negative 3.5 divided by 6.5. It's an estimate, and that's okay. And that's going to be then plus 276.923, 276.923, and that is also an estimate. Now, when I go to graph these two equations, we're going to go to the Desmos graphing calculator, and I graph them. And notice that those estimates are, I have 0.923. Here, I'll change it here. 0.923. There we go. All right. And I don't see those graphs. Where are they? Well, notice that the y-intercept here is 400. The y-intercept here is 276. So I need to change my scales here by quite a lot. Now, I'm not really interested in going too far into the negatives, but we're looking at pretty big numbers here. So let's go from negative 10, and I don't know how far I'm going to need to go. Let's say 100 right now. I have no idea really. And we're going to do steps by 10. It looks like it's already defaulting to that. And my y-axis, I'm going to go from negative 10 up to, well, I need to go to at least 400. So let's do 450. And then we're going to do steps by, it's automatically 50 there. That's fine. So notice that I'm going to need to go farther to the right because I'm not seeing these things at all. So, 100 doesn't look far enough, maybe 500. Oh, there we go. So now you can see, I can see my axes here, and that's nice. And I can then come here and look at the point of intersection right there, 266.4 and 133.6. So I've graphed the equations. That was step 4. And I'm going to write the solution here, and then I will go back to this so that you can all see that. 133.6. All right, now, when we look at that solution and we analyze, notice that the x is the number of student tickets. So just like before, I'm going to highlight that just so I'm like, oh yeah, that's the number of student tickets, and this is the number of adult tickets. However, notice that we have a decimal number of tickets. I cannot sell 0.4 of a ticket. This right here, I don't know what that means. It doesn't make any sense. So I'm either going to need to round down and round up. So round this one down to 266 and this to 134. Or I'm going to need to round up to 267 and this to 133. Now, we want to make sure that we make at least $1,800. So it makes more sense to round up the adult tickets. So in this solution, they would need to sell, 266 student tickets and 134 adult tickets. Now notice that when I write this sentence out, I use the full word tickets. Yeah, because I'm analyzing the situation, I'm responding in context, and I don't want to use a word that's not really a word, ticks there. So that is how we can solve a real-world system of equations, and we ended up using some graphing technology in there as well.